This example is on solving linear inequalities. So we've got two examples to look at. First one, solve the inequality 5x minus 3 is greater than or equal to 12, where x is an element of n, and then graph the solution on a number line. So we're going to break this question down into a few different parts. The equation itself, 5x minus 3 greater than or equal to 12, you will solve that normally while treating the sign in the middle like an equal sign. This part here then, which says x is an element of n, what that means is x is a natural number. And then we have to graph the solution on a number line. So that's what we're going to do at the very end once we figure out what the x is. The signs in the middle, you've got four different signs. You've got a greater than sign, you've got a greater than or equal to sign, you've got a less than sign, and you've got a less than or equal to sign. So for this example, it's going to be greater than or equal to. You'll see a bit more of that as we go along. Solving this equation, what we normally do, we need to target this minus 3 and we need to try to get rid of it. In order to get rid of it, I'm going to plus 3 on the left and I'm also going to plus 3 on the right. So then I've got 5x is greater than or equal to 15. Then I've got 5 in front of this here, so I want to get rid of that by dividing by 5 on both sides. 5 divided by 5 is 1, so x is greater than or equal to 3. Now going back to the two pieces of information from the start, it says first of all that x is an element of n. So the natural numbers here are positive whole numbers. We know that x is going to be greater than or equal to 3. So if it was a number line, you would know it goes in that direction. And then it says graph the solution on a number line. So when I'm going to graph the solution on a number line, I'm going to draw out my number line first of all. So here's my number line drawn. And then it says x is going to be greater than or equal to 3. Now think of a number line. Greater than or equal to is going to go in this direction. So yes, first of all, it can be equal to 3. And it can also be equal to every positive whole number after that. So it can be equal to 4, it can be equal to 5, it can be equal to 6, it can be equal to 7, it can be equal to 8, and it can be equal to 9. And then it can also keep going on forever. So we put an arrow at the end to show that it can go on forever. Second question, solve the inequality 4 minus 3x is greater than minus 5, where x is an element of z. So this time x is an element of z is all your positive or negative whole numbers. And finally, we have to graph the solution on the number line. So we're going to take it one step at a time. We're going to write the question down first of all, and we're going to try to solve for x. So the first thing we need to do here is to target the 4, and we need to get rid of it by minusing 4 on both sides. So minus 3x is greater than minus 9. Now this is then a special case with inequalities. If I'm going to divide by a minus, if I'm going to change the sign in front of the x, I also need to flip the inequality sign in the middle. So instead of being greater than, it's now going to become less than, and it's going to become less than 3. So just to go through that again, if I'm going to be dividing by a minus, because I want a plus x, if you're dividing by the minus, so if you're changing the sign in front of the x, you must flip the inequality in the middle, and then the rest of it stays as normal. So then what we need to do at the end is graph our solution on the number line. So for this example, the arrow is going the opposite direction this time. So it has to be less than 3, and it's x is an element of n. x is an element of z. So that's all your positive or negative whole numbers. So it cannot be equal to 3. It can be equal to the first number less than that, which is 2. Can also be equal to 1. Now, since it's all your positive or negative whole numbers, it can also be equal to 0, minus 1, minus 2, minus 3, and it continues on forever as well. So we put the arrow in the end to show that it continues on forever.